To decipher how to do this, I started by constructing a mind map to help put my ideas down so I could visualise the process. Starting out with the basis of solar-powered electricity, I began to think of all the processes I will need to come up with the final answer. As pictured in the diagram, there are many different steps required to complete the answer. Not only did I need to understand the steps needed to come up with the answer, but I needed to know the mathematical computations I would be using within the calculations. The first step I needed to do was to calculate the area of my roof to help determine how much room I had for solar panels to be successfully used on my roof. I measured the length and the width of the roof and calculated using the pictured equation, length times width, and came up with my answer of 155.8 metres squared. The roof is northwest facing, so panels will need to be slightly angled for optimum performance. Using this information, I then began researching solar-powered installation companies and found a company called Energy Matters that had an inbuilt system on their website. I could input my correlated details and receive a quote with all the requirements. I needed to move on to the next step. The quote had the solar panels in millimetres, so I converted them to centimetres to make it easier for my next equations. I then needed to convert the solar panel measurements to metres to have matching units of measure. I then added together the length of the combined panels and separately from the width of the combined panels to enable me to form a diagram of the area of the solar panels. My final calculations for this gave me the area of the panels, so I could then move on to my next stage of calculations. The pie chart shows the total percentages of coverage of solar panels on the roof. To get to this answer, I used the pictured equation to determine the answer by dividing the solar panel area by the total area of the roof, then finishing off the equation by multiplying and dividing to give me the final answer in percentage form. The pie chart clearly shows there is enough space on the roof for the solar panels. Next, I used my personal electricity bill from this quarter to find the figures I needed for the next equation. I needed to calculate the number of days in the quarter billing cycle I was using. This was a simple addition equation, adding up the days from each month. Next, I used the information from my energy bill regarding daily usage from this account, which was 30.88 kilowatts an hour per day. The next phase was to work out the figures for both the non-renewable energy usage for the 90 days and how much energy was produced from the solar panels during the same 90-day period. These were simple multiplication equations using the numbers generated from the previous equations. The next part, working out the percentages for the pie chart, was slightly more complicated as it required multiple equations to come up with a final answer. Starting with total energy used minus the energy generated from the panels, I came up with the total usage from the grid for 90 days. Dividing this into daily consumption was the next equation, which enabled me to then work out the percentage of energy used from non-renewable energy, which is shown in the pie chart. The next component was to work out how much money could be saved from the current energy billing cycle. Using the charges from each block of the electricity bill and adding them together gave me the total usage charges for the 90 days. Just as the usage charges were used No other costs involved in the bill were calculated within this equation. As shown in the calculations, using the 61.11% from the previous calculation, I was able to calculate the total savings for the 90-day period, which was quite a large sum of $391.16. My final task was to calculate whether or not I had reduced my carbon footprint through installing and using solar panels in my home. Using the ecological footprint calculator from the WWF website, I calculated both my pre and post solar panel footprint usage. Using these figures, I calculated my footprint had reduced by 20.41%. This was from making one change. I can only imagine how many more can be done with more changes to our ecological footprints.